Welcome to This Explainer. Today we're embarking on a truly cinematic journey. We're going to travel all the way from the infinite, sprawling cosmos, right down into the invisible, subatomic realm. And along the way, we're going to uncover exactly how modern science operates on these massive scales, fighting to separate hard, verified facts from those tantalizing scientific hypotheses that keep scientists awake at night. We'll be diving into the incredible machinery and the generations of minds completely dedicated to solving the universe's absolute greatest mysteries.
So, think about this for a second. What connects the very edge of the universe to the smallest invisible particle? Well, the answer lies in the awe-inspiring scale of human ambition, specifically our massive discovery machines. Whether it's peering billions of light years away into the ancient past or smashing particles together at practically the speed of light, the machinery required to push the boundaries of human knowledge is just staggering. These aren't just tools, right? They're monuments to our fundamental need to understand exactly where we come from.
Exploring the secrets of the universe for the benefit of all. Now that happens to be NASA's vision statement, but it perfectly echoes the driving force behind all major scientific endeavors worldwide. It takes immense human drive and unprecedented international collaboration across massive organizations like NASA, the European Space Agency, and CERN to probe the unknown. No single country or institution can build these monumental discovery engines alone. It literally requires thousands of minds pooling their expertise, funding, and passion over decades to make world-changing breakthroughs.
Section 1. Probing the Deep Cosmos.
Thanks to the James Webb Space Telescope, we now have verified discoveries of interacting galaxies captured in absolutely stunning detail. Before megamachines like JWST, these deep regions of space were just blurry, distant mysteries. Now, scientists are actually watching immense galaxies pull each other apart and merge in real time. By using incredibly sensitive infrared sensors to peer right through thick cosmic dust clouds, JWST made this verified observation possible, and it completely surprised scientists, forcing us to rewrite the textbooks on how early galaxies actually formed and evolved.
But you know, science is a living, breathing process, and the search for answers is always ongoing. Right now, millions of miles away, on the dusty surface of Mars, the Perseverance rover is methodically drilling and collecting core samples. Recently, it uncovered these really intriguing leopard spots on a rock nicknamed Cheoval Falls. These tiny, millimeter-sized markings sent absolute shockwaves to the scientific community. Why? Because they look suspiciously like the chemical signatures and structural patterns left behind by ancient colonies of microbes right here on Earth.
And this brings us to an absolutely crucial point in scientific discovery. We have to distinguish between what we know and what we suspect. On one hand, we have a verified fact. Extensive data collected from decades of rover missions has proven, without a doubt, that Mars once had flowing liquid water and habitable environments. On the other hand, we have a thrilling scientific hypothesis, the idea that these specific leopard spots actually indicate ancient microbial life. We definitely don't know that for sure yet, but if this hypothesis becomes verified fact once those samples are brought back to Earth, it will undeniably be the greatest discovery in human history.
Section 2. Decoding our changing planet. Consider the year 2025. This number represents a verified and frankly sobering scientific discovery from the National Oceanic and Atmospheric Administration, NOAA. By aggregating data from thousands of weather stations, deep ocean buoys, and advanced climate satellites, they maintain global temperature records dating all the way back to 1850. And after meticulously crunching the numbers, their data definitively confirms that 2025 ranked as the third warmest year globally on record. This isn't guesswork, folks. It's hard, verified data showing exactly how our world is transforming.
The sheer scale of this verified data is honestly staggering. We're measuring extreme heat across land and oceans and tracking record-high upper ocean heat content. But what truly surprised scientists here was the extremely low sea ice extents in both the Arctic and Antarctic. It drastically outpaced a lot of predictive climate models. The ice melted significantly faster than anyone expected, which signals a rapidly shifting climate system that's behaving in much more extreme and unpredictable ways than we previously hypothesized.
But, hey, not all of Earth's dynamic forces are visible from space. Beneath our feet, there is this hidden, mounting suspense. The U.S. Geological Survey is actively mapping these hidden threats through continuous geological research. They're using advanced 3D seismic velocity models to simulate extreme tsunami and earthquake hazards at the Cascadia subduction zone. Simultaneously, they're tracking terrifying tectonic stress that's accumulating along the San Andreas fault system, trying to assess the threat of imminent ruptures in Southern California. The hazard is entirely real, and this relentless ongoing research is absolutely our best tool for survival.
Section 3. Smashing the subatomic frontier.
Now, to study the invisible building blocks of literally everything, we need a hadron collider. It's a massive machine that accelerates heavy elementary particles and smashes them together at extreme speeds. Because these particles are relatively heavy, they actually avoid losing energy through a phenomenon called synchrotron radiation, which is basically energy leaking out as the particles curve around the circular track. This brilliant law of physics workaround is exactly what allows these colossal discovery machines to reach completely unprecedented collision energies.
And harnessing those extreme energies leads to moments that change physics forever, like the verified discovery of the standard model Higgs boson at CERN's Large Hadron Collider. To make this groundbreaking discovery, physicists had to push collision energies to unimaginable extremes, essentially creating microscopic environments similar to the very dawn of the universe. Finding the Higgs boson was a massive triumph because it finally proved exactly how fundamental particles get their mass, turning a decades-old theoretical hypothesis into an undeniable foundational fact of nature.
But, as always, the subatomic frontier is never truly conquered. Contrast that verified Higgs discovery with the agonizing, highly suspenseful hunt for supersymmetry. Supersymmetry is this beautifully elegant scientific hypothesis suggesting that every known particle has a heavier superpartner. Proving this could potentially solve the mystery of dark matter, the invisible stuff holding galaxies together. Particle physicists are desperately chasing these theoretical interactions, but the data just hasn't confirmed it yet. It remains one of the most exciting and, let's be honest, frustrating ongoing mysteries in physics today.
Section 4. The next scientific leap.
So, to make the next monumental leap in understanding, we really have to respect the multi-generational aspect of the mega machine lifecycle. It takes literal decades of global collaboration to build these instruments. Just look at the high luminosity upgrade of the Large Hadron Collider. The research and development for its superconducting magnets actually began in the early 2000s. The current LHC run ends in 2026, and the new upgrade won't even be fully operational until 2029. We're talking about a 25-year, multi-generational commitment of scientific stamina just to push the boundaries a fraction further.
Mapping out our scientific future requires a level of technological ambition that is almost hard to comprehend. When we compare past colliders with colossal future proposals like the Future Circular Collider, which aims to use massive, incredibly powerful 20 Tesla magnets, we see a steep, almost impossible climb. Pushing the boundaries of discovery isn't just about dreaming up big ideas. It's about the grit, the unprecedented funding, and the relentless stamina required to build machines that completely defy the limits of current human engineering.
Which brings us to our final thought for today. Will our next generation of mega machines finally reveal the ultimate unifying theory of everything, or will they just uncover deeper, darker mysteries that we can't even begin to comprehend? It's a thrilling unknown that keeps the scientific community pushing into the dark. Thank you so much for joining me on this explainer as we explored the incredible scales of scientific discovery. Until next time, keep questioning the vast universe around you.